Welcome back to another set of examples. In this case, we are going to work with determinants. And as I mentioned in the previous video, that we're going to do quite a few problems when it comes to determinants because there's many ways to solve them. And then also there's like the specific case of of calculating determinants, whether like some conditions are met or it's in some form, or just the general way of determining matrix. In this first example, we're going to be discussing about manipulating determinants given a matrix. So in this example, we're going to let matrix A equal to A, B, C, D, E, F, G, H, I, which is a 3x3 matrix. And we know that the determinant of that matrix is equal to 3. And so now it wants us to find the matrix or the determinant of this matrix that has been manipulated right here. So we know it came from the matrix A, but it's just been done some weird things to it. So what we're going to do here is we're going to figure out how do we go from matrix A to this new matrix. And so we can do the row operations, and remember, when we do row operations, the matrix also changes depending on what you do. There is a specific row operation that does nothing to it, but we're gonna see what they did to get this new matrix and then see what happens to the determinant. So on the first one, we can do probably one of the most obvious ones was that the row or the second row went down to the third row. And so what I'm going to do is I'm just going to rewrite matrix A and then do the row operation where row 2 and row 3 flipped. And so what ends up happening is that the determinant gets multiplied by -1. So that means our matrix or our determinant of A would just be equal to -A. And what ends up happening is we get A, B, C, and then G, H, I, then D, E, F. And now this is going to equal to, we're going to keep track of the determinant. This is going to be equal to, we're going to make this in blue. 3 times -1 is -3. And then what we're going to do now is we're going to see that the second row has now been doubled. So we know that the new second row is going to be twice as the original value. And then what we also know is when you multiply a row by any scalar, it also gets multiplied by that new scalar. Determinant will now be twice. So this would give us A, B, C, and then to G, to I. Whoops. Let me space these out. So A, B, C, then to G, to H, to I, and then D, E, F. And then our determinant is going to be equal to twice the original one, or what it was previously, and that'll be -6. And so now it's figuring out what happened on the first part. So if we were to ignore the addition or like what's been added, we can see that the first row has just been doubled. And then after that, it's just been added by 3 times the third row. So what I'm going to do is first double the first row So it'll be 2r1 equal to the new r1. And so like in the previous step, the new determinant would just be twice what it was previously. And so that would just be 2a, 2b, 2c, and then 2g, 2h, 2i, and then d, e, f. And so our determinant will now be twice -6, which would be -12. And then lastly, what they did is they got the first row and they multiplied 3 times the third row. And if you recall from the lecture, that if you add a row by a multiple of another row, the determinant will remain the same. So now what we end up getting is 2a plus 3d, 2b plus 3e, and then 2c plus 3f, and then 2g, 2h, 2i, and then d, e, f. And our determinant, which would be our answer, will still be the same. And so this is our answer for the first question. So now we're going to move on to the second question. So for the second question is going to ask us to calculate the determinant of this 4x4 matrix. I did mention that to calculate any determinant of a matrix with the dimension 3 or higher, you have to do square reduction. But in this case, we can see that you can kind of convert this into a diagonal matrix. Literally just by changing a couple rows. So what we're gonna do is we're gonna flip the first and last row. So that's gonna be R1, R4, and that will give us 2, 1, 0, 0, 0, 0, 1, 4, 0, 3, 1, 2, and then 0, 0, 0, 3. And so what ends up happening is that the determinant will just now be negative. We're just gonna let this equal to a. And then what we're gonna do now is we're gonna flip the first and not the first, the second and third. So now it's gonna be the second and the third, and then we multiply that by a negative, so that will just give us back the original one, and then it will be 2, 1, 0, 0, 0, 3, 1, 2, 0, 0, 1, 4, and then 0, 0, 0, 3. And then if you see here is we have a triangular matrix. And so if you recall, if the matrix is a triangular matrix, whether it's upper or lower, it doesn't matter. The determinant will literally just be the product of the diagonals. So the determinant would be 2 times 3 times 1 times 3, and that is equal to 6 times 3, which would be 18. And that's our answer to the second question. So I'm going to go ahead and stop right here. There is going to be another type of an example, and that one would be involving 3x3 matrices, and as well as, I believe, another 4x4 matrix. And so what we're going to do is we're going to solve both of them in different ways. So with the third one, we're just going to do the expansion and then the square reduction, since it's a small one. And then for the fourth and final example, we're going to do the block method, which, like I mentioned before, it has to meet a certain condition. And so once when that condition is met, we can go ahead and do it. And so in that example, I'm gonna show y'all what the condition is, and as well as what to do when the condition is satisfied. So I'll see you guys in the next video.